Okay, so what we're going to do is we're going to understand that all of this copper 2 chloride is going to get used and it's going to react with this sodium nitrate. So we want to know how much sodium nitrate is going to react with 15 grams of copper 2 chloride. So this is kind of like problems we've done before where it's been like, what's the perfect amount of sodium nitrate to react with 15 grams of copper 2 chloride? So that's what we're going to do here is a gram to gram stoichiometry problem going from grams of copper 2 chloride to grams of sodium nitrate. We're going to do that right here. Okay, so we do 15 divided by 134.45 times 2 times 85 equals 18.97 grams of sodium nitrate. That's how much sodium nitrate is needed to react with 15 grams of copper 2 chloride. We need 18.97 grams. We have 20 grams available. So what that means is that the difference between what we have available and what we need is the amount of that reagent that's left over. So that turns out to be 1.03 grams of sodium nitrate left over or in excess. Okay. The next question, if 11.3 grams of sodium chloride are formed in the reaction described in problem 2, what's the percent yield of this reaction? So you guys remember the aspirin that we made in lab? Some people had a little bit of aspirin that they made. Some people had a huge amount. And then a lot of people had something in between. And everybody did everything the same, or at least supposedly. Same amount of salicylic acid, same amount of acetic anhydride, same reaction temperature, same everything. But some people ended up with more aspirin and some people ended up with less aspirin. So the point is, in the lab, stuff happens, and you never end up making exactly what the math says you should make. So in a perfect world with this reaction, we should be able to make 13.03 grams of sodium chloride. But if we conducted this reaction in the lab with 15 grams of copper 2 chloride and 20 grams of sodium nitrate, if we only made 11.3 grams of sodium chloride instead of 13.03, that wouldn't be too surprising. So, one way you can think of it is kind of like a grade. Like if there's a quiz where there's 100 points possible and you got 85 of the questions right out of 100, then you would have gotten 85% on that quiz. So it's kind of like that. If supposedly 13.03 grams of sodium chloride are theoretically possible to make with this reaction, and you only made 11.3, then we could figure out what percentage you yielded as a percentage of the theoretically possible. So we call that percent yield, and it's equal to the actual yield divided by the theoretical yield. times 100%. It's just like calculating your grade. So if we actually produced 11.3 grams of sodium chloride, but stoichiometry tells us we should have been able to produce 13.03 grams, then our percent yield would be 86.72%. That would be our percent yield.